and then we would have a variable. Hello everybody. In this video we'll be working with sets. From section 1.3 way back in the day, you might recall that a set is a collection of distinct elements. Sets are the basis of mathematical language. You probably remember sets as being like whole numbers. That's a set of numbers. So the whole numbers is a set of numbers containing 0 and 1 and 2 and 3 and 4 and so on. We also have the set of natural numbers, which would be 1 and 2 and 3 and 4 and so on. There's also the set of integers or the set of real numbers. But it doesn't have to be just numbers. We could have a set of letters. For instance, here's a set of letters in my last name. And within these sets we would have subsets. For instance, a subset of whole numbers might be 3 and 5 and 6. Certainly all those numbers are whole numbers, so they would be a subset of the whole numbers. You could have a subset of natural numbers. A subset of natural numbers might include 1 and 5. You could have a subset of the numbers in my name. Letters in my name. So for instance, I, R, N, S. So that would be a subset of some of the letters in my name. There's a couple different ways you can show sets. You can put them in roster form. So let's say I have a set of numbers, and we'll say the set includes the numbers 1, 2, and 3. So I can put this in roster form, which you'll have to know what that means. And that basically just means listing it. And you put it in these things called braces. It's kind of like a bracket, but it's a little more squiggly. If you look in the book, it'll be more clear. My squiggly is not perfect. So if we put it in roster form, I just put all the numbers in there. But then there's also something called set builder notation. Not sure why it's called this. Notation. It also uses braces. And it uses a variable, so we just make up some variable. And then we would use a descriptor to talk about the elements in the set. So they're natural numbers. And you could have other ways of describing it. And also, it is less than 4. So every number in this set builder notation, the description of all the numbers would be 1, 2, and 3, right? Because they're all natural and they are less than 4. And there is no natural number less than 4 that's not included in this set. M is the set of integers that are greater than -1 and less than 4. So in roster form, I would make my brackets, or my braces, sorry, and I need an integer that's greater than -1, so 0, 1, these are all greater, 2, 3, and also less than 4. So I'm done. These are all the set of integers that are greater than -1 and less than 4. So if I wanted to put this in set builder notation, I would start with my braces. I would have a variable and put that vertical line and then have the descriptor, right? And so the description might be that M is an integer because it says set of integers. So M is an integer. And then another description is that it is greater than -1 and also less than 4. So that would be set builder notation for that. So let's say we wanted to write an inequality, which is what we've been doing. And my inequality is 5r plus 8 is less than 63. And I want to describe the solution to r in set builder notation. So first of all, just like we have been doing this chapter, we're going to solve this inequality. And so we have 5r is less than 55. And then we're going to divide both sides by 5. And we end up with R is less than 11. So how do we describe this in set builder notation? Well, we can say we first need our braces. We need our variable. So in this case, we're talking about R. Have that vertical line. And in this case, we're not talking about integers or whole numbers or decimals or anything. It's wide open. It hasn't been constricted that way. So we would just have to say R is less than 11. So the set builder notation actually looks very similar to how we might answer it previously. In the next problem, I'm going to list a set. Okay, so I'm just going to write a set of numbers. We'll call it 1, 2, and 3. And the instructions to this part of the assignment will be list all the subsets of each set. Okay, all the subsets. So the first set we can list So to list all the subsets need to be listed in braces. So 1 is a subset, 2 is a subset, 3 is a subset, but you can also have multiple things that are subsets. So for instance, 1 and 2 would be a subset of all that. 1 and 3 would be a subset. 2 and 3 would also be a subset. And also a subset, I'm not sure why they have it this way, but a subset is also all the numbers. So 1, 2, 3 would also be a subset. And there's something called the null set or the empty set, which can be written in a couple different ways, but you just show empty brackets to show that nothing would be also a subset of 1, 2, and 3. That's kind of a strange thing, but that's how it is. So one or two more examples I want to show you. We're going to start thinking of these sets and subsets as Venn diagrams like you saw back in 6th grade. So let's suppose we had a main set, which is also called a universal set, like so the biggest set of numbers that we're going to use. And let's say the universal set is going to be 5, 6, 7, 8, and 9. So using that universal set of numbers, suppose that we have a subset, we'll call it subset C, equals 6, 7, and 8. The question is, what is the complement to this subset? Okay, so the complement to a subset is the numbers that are not included in the subset. So the complement, also known as C prime, is going to be what's not listed here. So 5 and 9 is the complement to that subset. Notice if you put all the numbers from the subset and all the numbers from the complement of the subset, you end up with that universal main set. And you can think of this in terms of a Venn diagram. A simple Venn diagram, actually. So we'll call this whole box here the universal set of numbers, and then we'll call this circle. We'll call this subset C, and we'll put the numbers in there that are part of subset C. And then everything that's not part of subset C, we would call C prime. That would include the numbers not involved. So remember, this whole box would be the universal set, and notice this 5, 6, 7, 8, and 9 are all there in that big box. The circle is the subset C that we're talking about, 6, 7, and 8, and the complement to the set is a C prime, and that's the 5 and 9 that were not included in here. So let's try another one of those. Suppose we want to have a universal set. In this case, we'll do letters, and we'll might as well do letters in my name. So we have S, we have I, we have N, C, L, A. We already did I, so then R. Sinclair. And let's say the subset we're going to use has the letters I and N and R. So first of all, what's the complement to subset A? And then we want to draw a picture of the whole universal set and then the subset and the complement. So the complement is going to be called A prime, and the subset is, or the complement to the subset would be S and C and L and A. And if we were to draw a Venn diagram of this, now this is a Venn diagram that only has one circle in it. We've done more complicated ones before, and we could do that again. But for this case, we don't really need too much of a complicated issue here. So in the circle, in the set, we have I, N, and R. And then still part of the universal set, but in the outside would be S, C, L, A. And notice that whole box here represents the universal set, which is S, I, N, C, L, A, R. Here's the subset. Oops, we want to call that subset A. And then here is the A prime out here. All right.